Welcome to the presentation of our latest innovation, the SET system, Safety Advanced Technology. Let me give you a little bit of background, how we set up this innovation and where it comes from. In South Africa, we do a lot of trainings with our partners, especially in the mining industries. There is one special risk that cannot be avoided. This is a potential risk of a leakage in the hose. Of course, when we set up an oxy-fuel system, we work out a leak detection on all connections, at the regulator, at the flashback arrestor, and at the handle. But what happens if there's a leak inside a hose, which can even underground or in the chip industry sometimes have a length up to 200 meters. It can be caused by sparkles from welding or somebody pull it over a sharp edge. This is something we cannot detect and we cannot avoid. With the development of the SET system, we found a solution to avoid these risks and bring more safety to the industry. Let us start with the first setup, which we will present to you together with our colleague from the Application Techniques, Florian Mollwitz. The first setup will be the standard setup as we use it for oxy-fuel all over the world. Therefore, we have the connection to our oxygen cylinder with a working pressure for this nozzle of 7 bar, and we have our acetylene cylinder set up to a working pressure of 0.7 bar. And you see here in the line on the right-hand side, we have our flashback arrestor, the hose that goes directly to the torch. In the first step, we will light up the torch, adjust the torch, and then we have a special demonstration device here which simulates a leakage, a massive leakage inside the hose. What is important for you and also important for all workers in the field. While working, if you have a huge leakage inside the hose, there's no chance for the worker to detect it because there's no change of the flame. So also while this presentation, when we light the fuel gas here, please have a look on the flame on the torch. There will be no changing. As you see, even while there was a massive leakage in the hose and the acetylene was pouring out in a huge volume, the flame doesn't stop and even doesn't change the settings. Now let's come to the second setup, which is our new SET system. The SET system belongs of a SET valve and a torch. In the first step now, as we started on the right-hand side, we will switch the device to the left side and to the connection of the SET system. Now we will just open the valve here to get the acetylene's flow through the system. In the first presentation, we will do the same procedure as before. We will light the torch and also simulate the leakage inside the hose. The first important thing, and maybe you will be a little bit impressed, the starting procedure is a little bit different. In the first case, we will open the fuel gas valve by one turn. Now let's see if gas is pouring. You see, no gas is coming out. Now, we will start the torch as before. Therefore, we open the oxygen valve and ignite the flame. We will do this again, but after that, we will take again our leak device, and you will see I will open the valve completely, put a flame here, and look what happens. You see, no gas was pouring out. And even when we open the valve more and the leakage becomes more massive, the flame died. Now let's do one step more. Therefore, we will remove the acetylene hose with the device. And on this place, we will put in a clear hose. In this presentation, we will light the torch and we will simulate what happens if a complete acetylene hose is burned, maybe by the sparkles from welding. The procedure is equal. We can open the fuel gas completely, check again, no gas is coming out. We open the oxygen, light the torch. And now have a look here. You still see there is no acetylene in the hose, no fire, no explosion. Finally, some explanations for you, because sometimes it seems a little bit spooky how this system works. The idea behind is quite easy. What happens here? Messer itself developed a special torch with a new designed head, which is working with an injector that creates a negative pressure. In this case, this patent system, and this is the only one in the world, creates a negative pressure of minimum minus 0.4 bar. What does this mean for us? The negative pressure is created by the oxygen. In case we open the oxygen and the fuel gas valve is open, in the fuel gas line up to the valve, we have a negative pressure of 0.4 bar. This is a demand valve or a negative pressure valve that opens only when a negative pressure reaches the valve, and when it opens, the gas can pass through. This valve is also patent, as well as a complete system consisting of valve and torch. At the moment the valve opens, the fuel gas can pass through and we can ignite the torch. At no time there's a positive pressure inside the system. That was the reason why we were able to simulate the leakage and no gas was pouring out. In case the leakage is too massive, the negative inside the hose will be reduced up to a point that the valve will close. Then no more fuel gas is pouring, the system is closed, and the working is safe. Thank you very much to joining this presentation, and we hope that you agree that with this system we bring the latest innovation for safety and industry in oxy-fuel handling to the field.